So after this little thing here, you'll know what the terms valence and combining capacity refer to. Be able to create ionic monovalents that do not bond one-to-one. I sort of showed you a little bit of that yesterday. Be able to write formulas for ionic compounds. That's kind of an extension from yesterday. And be able to name ionic compounds. And I don't mean like just call them Bob and stuff like that, right? There's a little bit more to it than that. Yes. Hello, Bob. All right. So do you need to do any write-ins here? There might be some. Yes, there might be some. So the valence or carrying capacity is another name for the charge that an ion creates when it either loses or gains electrons. And you should remember that when it loses electrons, it then becomes positive, and when it gains electrons, it then becomes negative. Okay, that should be, you got to know that. You got to know that. Okay, so for example, Mg, and I put away my meter stick. Oh, here it is. Mg, up here on the good old periodic table, is in group number 2, so it has a valence or a combining capacity of +2, because it's going to give away, right? So what happens when the positive and negative valences are not equal to each other? Well, you should get that here better. So for example, if I got Mg, which is a +2, and F is a -1, what do we do? Well, it means what? And this is how you show it with Lewis bonds, right? So if Mg is a +2, Mg is in the group 2, right? So it's got 2 valence electrons, and you guys can draw this in there. And F, I'll just use X's for its electrons, looks like this, right? So if you put this blue one in here, he's got 8, he's good. But then where does the other one go? I showed you this a little bit yesterday. What do you need? You need another F, right? You need another F. And we showed that yesterday with the paper things, right? I showed you how to do that. Right? Same thing with aluminum and chlorine. I'll pause. So this one here, what's the formula here? How many ALs do we have?
1.
How many CLs?
3.
So we get the ionic compound AlCl3. Isn't that ionic?
So how can we put Al first?
I was just about to say, how do we know which one we put first? Say again, Kevin? That's not a bad answer, but unfortunately it's wrong. But it's not a bad guess. Here we put the Mg first. The reason is this, or the convention, I guess is a better way to put it, is whatever is the positive one, Charles. So you put the +1, the +2, or the +3. The metal comes first. I don't know why. Left to right.
So if they're both negative.
Then you got what's called a covalent bond, which we'll get to.
And a positive.
Yeah, we'll get to that.
Oh.
We'll get to that. Okay, so now you could do this with the manipulatives, right? I showed you sort of how to do that yesterday. There is a bit of an easier way. And I used to show this. This was the only way that I showed you. But I think the manipulatives actually help for some people. So I will be sort of reverting back to those in some cases. But here's sort of, says the easy way. Yours says the crossover way. I thought I fixed this. I know I fixed this. I know I fixed it. So it should say the crossover way. So calcium and iodine. So you write the metal symbol with its valence, and then write the non-metal symbol with its valence. So you got Ca and I, calcium and iodine. So Ca is in group number 2. So we're going to write that as a 2 positive. Again, we write the metal first. Iodine is over here in group number
7.
Which is a valence of -1. Right? And I'm going to do it in a different color because I know I need to. Okay, and then here's the step. Crisscross the valences to become the subscript. So this 2 goes down like that, and the 1 goes down like that, and your formula becomes CaI2, just like that. Okay, now can we do that with the manipulatives? Absolutely. If I'm doing it with manipulatives, Ca is a +2, right? So that's this one here. Oh, this is the wrong one. I got the wrong batch. I hope I'm not confusing you too much here. So Ca is the +2, and I is the 1 minus, right? So this is an I right here. So I bring out my Ca, and I bring out my I, but because I got that empty spot, what do I need? I need another one. Right? So what's my formula? CaI2. Right? You don't need the manipulatives. You can just do it with the subscript. So in other words, let me just show you again here, right? The Ca is a 2 positive. The I is a 1 negative. Now really, Charles, we're not taking the positive and the negative. We're really just taking the number. Right? So I mean, you don't need to, you see the 2. I did this to sort of show you visually, but really we just take the number 2 and put it down there. And when you're dragging the 1 down there, right? But you don't take the negative, you just sort of take the 1. So it's CaI2. Do I need to write the 1? No. It's just like the number in front of the X kind of thing, right? You don't need the 1X. So does that work okay for you, that Chris? If you want to use manipulatives, you go right ahead. If you want to do it this way, you also go ahead. Yeah, this way's a little quicker. But sometimes it can get a little confusing. It's nice to have the manipulatives as a fallback or as a check. Do you want to try a couple? You got lots of room there. I'm going to do attendance. You guys try those, and then I'll give you the answer. If you need manipulatives, you go right ahead. Okay, well, let's do it the crisscross way. So aluminum and sulfur. Aluminum is a 3 positive, and sulfur is a 2 negative, right? So 2 negative. So you crisscross them, and it's not going to work because I didn't do it in a different color. I'm going to put a 3 there and a 2 there. So you just do what? And so your formula is Al2S3. How would I show that with manipulatives? Al was a 3, right? So that's this guy down here. So I'm going to bring this guy out. But sulfur was a 2, right? So I need this one here. But the problem is what? Not enough. So this is Al and this is S. So I need another one of these. Right? But then what happens? Well, now I got an empty space. So now what do I need? I need another one of these. But now when I do that, what happens? Well, now I got, right? So now I need another one of these guys. And now it's all going to work out, right? And so how many ALs do I have? Al2, and I've got S3. So with the manipulatives, like, it takes a while, right? And I don't think you have 3 of these ones, do you? Right? But you could probably, oh, okay, yeah, once I get that, you could probably do it without. If you want to cut one out, you can. But the crisscross kind of helps you do some of those. What about nickel and oxygen? Did you do this one? Are you ready? You attempted it? So what you're saying is I should do it?
Yeah.
Okay, where's nickel? It's in the middle. Oh.
Yeah, that's what
It's kind of weird. Nickel is weird. Oh. Let's go to this part. Nickel is weird. So just to make things interesting, because, you know, life has to be interesting, there are some metals that can give away different number of electrons. They are listed on page 195, and they're shown here as well. You don't have that textbook anymore, okay? So they are copper, iron, lead, tin, and I believe nickel. If I'm not mistaken. Nickel is, oh, maybe not. Nickel is 5, 6, 7. I'll have to double check that nickel. But anyways, so these ones here, copper, iron, lead, and tin, they can either give away a 1 or a 2. Iron, a 2 or a 3, lead, a 2 or a 4, tin, a 2 or a 4, okay? And you put the Roman numeral 1 or 2 or 3 or 4 in front of them, or behind them when you're talking about which one it is, okay? So this means that they can take either form as needed. Do you guys have this as well? You have this, right? Yeah. You have to skip a little bit there. So are you on the back page? You're on the back page? Yes? On the back page there. So this means they can take either form as needed. So for example, copper and chlorine can form two different compounds. Okay? So if it says copper 1 chloride, then that means we use the copper that gives away. We use this one. Okay, does that make sense, Brandon? Copper 1 means it's the one that gives away 1 electron. If I said copper 2, then it's this one here, right? Okay, so copper 1 chloride. So that means that when you do the crisscross, Charles, we're going to have Cu, we're going to have the +1. Chlorine is automatically a 1 negative. You crisscross those ones and you get Cu1Cl, which really is just CuCl. Does that make sense, Logan? Yeah? Following? Yeah, AJ? I'm speaking English? Okay, just making sure. Now, if I gave you copper 2 chloride, that means what? It means that we're going to use this one that gives away 2 electrons. It's a different kind of copper. That's all I'm going to say. Different kind of copper, right? So now I'm going to write the 2 up here. The chlorine is still a 1. Do the crisscross and you get, whoops, these should have been different colors. Bring the 2 down, the 1 down there. You get CuCl2. Okay, Charles? Yeah? Jesse? Good? So, I'm suggesting, no, I'm not suggesting that. I'm not going to bother the textbook probably. You want one? Yeah. I'm suggesting that you take that back page. Did I do it? Yes, I did. I'm suggesting you take this page here and write on the transition ones. Okay? Because they can tend to confuse people a bit. So I'm going to help you with that because I'm sensing some confusion here. So take this one, and I do have it, I know. Yes. Okay. So what was that list? And if you want to write these on before, let's do that. Let's write these on together before we cut them out, okay? So which ones are 1 positive from that list? Copper. So that would be Cu1. I think that's the only one that's a 1, right? Cu1. Okay, which ones are 2? Well, copper 2, Cu2, iron 2, Fe2, lead 2, Pb. You guys know why the symbol for lead is Pb? The Latin word for lead, the original term for it, was plumbum.
Oh, I learned that last.
Which-
Yeah, my dad taught that one.
Which is why, because pipes used to be made out of lead, so the guy that comes to fix your lead pipes is known as the plumber. And that's why he wears his pants the way he does, because it's part of the rules. Good to know. See? There's your joke for the day. Plumbum. Tin, Se, strontium. Not near as much fun. Yes. Fe is iron, ferrous. Au is aurum, gold. Silver. What is silver again? Ag, agrium, I think. Okay, so Cu2, Fe2, Pb2, Sn2, right? Okay, do we have any 3s? We have an iron 3. So Fe3. That's the only one for a 3. And we have a couple of 4s. We have lead 4, plumbum, Pb. 4 is an IV. Did you guys know that?
Yes.
I think some modern Roman numerals puts like 4 ones, but yeah, I don't. And tin is the other one, so Sn4. So I would suggest you cut those out. I'll get Mrs. Coombs with scissors again, and we'll do that. But I should talk to you about naming. I did this kind of backwards here. I thought I had this all set up perfectly, but you never know how it's going to work out in front of a class. So can we go back to the naming part? Then I'm going to give you some. Oh yeah, I don't have that one here. Let's go back to the naming part. Naming ionic compounds, super crazy easy. Nothing could be easier. Okay? You write the name of the metal first. You write the name of the non-metal second, but it must end in "ide." So you change it so it ends in "ide." So calcium and iodide becomes calcium iodide. Aluminum and sulfur becomes aluminum sulfide. Did you find it, Desiree? Flip the page over. Yeah. Nickel and oxygen. Nickel oxide. Please don't get this wrong in the test. It's super crazy easy. Okay? I'm going to go borrow those scissors again.